So who remembers this equation from algebra, pre-calc? Do you remember this equation?
It's the quadratic equation.
Yes, it is specifically how to find out where the function is equal to 0, at what x points the function is equal to 0. In this format, ax squared plus bx plus c is equal to 0. Now, why is this important? It's important to realize how we got it, how we simplified the equation like that. Now, it took some effort, but some brilliant mathematicians figured it out. And we're gonna go piece by piece, so maybe you can think about multivariable algebra a little more differently and a little more accepting of its nature. Let's divide each side by a. This is the same as saying, by the way, this is the same as saying all of this over 1a, but we're just splitting it up between each term that's being added together. So when we do it like this, this and this cancel, but it doesn't cancel for these terms, so we're left with x squared plus b over ax plus c over a is equal to 0. 0 over a is equal to 0. 0 over anything is equal to 0. That is true. Now, what do we do from here? Let's move this to that side so that we can isolate our x's in a way, so to speak. So now we have x squared plus b over ax is equal to negative c over a. Now what? What if we try doing this? Well, that's not going to work. If we try doing that, well, c over a, sorry. That's not going to work because that's implying, if we were to try to do this and solve that way, like you know, or as you would with x plus 1 is equal to 0, at least in this scenario, if one of them is equal to 0, the other one will cancel out. But we don't have that scenario. We have this, and if one of them is equal to, one of these factors is equal to c over a, it doesn't really cancel anything out. It doesn't help us. So that's out of the question. But there is a very, very interesting and sort of unique way to go about this. So if we remember, if we move over here, let's think of a plus b. No, since we're already using a plus b, let's use u plus v squared is equal to u squared plus u plus 2uv, my bad, 2uv plus v squared. Now let's format this in a way so we can have our 2 clearly written there. So let's make a connection between these two already. Let's make that early connection. We have a squared value at the front. We can obviously put these two together. To put 2 and 2 together, we can put x squared and u squared together, 2 and 2. U is equal to x. So by that logic, we're going to have 2uv. We don't have a 2 here, but we want to visualize the 2, so let's put a 2 in there. So that will be x squared times plus 2. Well, we can't put a 2 there because that will change our function, so we got to put a 1/2 in here, b over a times x. Now what will this be so that we can complete the square and condense the function, this function, from this form down to this form, where we can really do some quick maths? Well, what do we do? Let's think of the middle function. If u is equal to x, then what will 2u be? 2u will be 2 times that inner piece without the x. So we have 2 times 1/2 b over a So that's b over 2a. So if that's so then that must be equal to u, because if we set these equal to each other, we can cancel out our 2's. So we're left with 1/2 b over a, that's b over 2a. So what can we add to our function to make it equal to that? Well, we can do plus, and nope, that's not u, I'm sorry, that would be v. So if that's v, we're missing our v squared, so what is b over 2a squared? Well, that would be b squared over 2 squared, that's 4, a squared, that's a squared, b squared over 4a squared. So now let's add from this. These here are the same, mind you. I just multiplied it by 2, but immediately also multiplied it by 1/2. So if we were to mathematically think about it, these would cancel and these would mathematically be the same. Now, we're going to change the function on this side by adding our v squared component so that we can complete the square. So v squared is equal to b squared over 4a squared. But that changes our function here. So we gotta add b squared over 4a squared on that side as well. So we have negative c over a plus b squared over 4a squared. Now, from here, we have x squared plus 2 times 1/2, or b over 2a x plus b squared over 4a squared is equal to negative c over a plus b squared over 4a squared. Took a while to write out. But hey, look here. Now we have our u squared plus 2uv plus v squared. This is our u squared. This is our 2 times u times v, or times u times v. And this is our v squared right here. So now, let's move everything back atop. So if we have this, if we have completed the square here, we can take our function from this format and condense it down to this format. We set u equal to x, so we can write this as x plus, what is v again? Well, v is equal to b over 2a, so that's x plus b over 2a squared. Now, what is that equal to? That's equal to our left side right here. Let's put our positive component first, so that's b squared all over 4a squared minus c over a. Now, what can we do to get a out of the denominators? Or what can we do so that we can put this all in terms of one function over, or like one numerator over one denominator? Well, what we can do is set this equal to b squared over, well, this stays the same, b squared over 4a squared. And now we gotta have the same denominator. So a times 4a will be 4a squared. So let's multiply the top and the bottom so as to keep this the same. If we multiply 4a on the top and the bottom, 4a over 4a, that's equal to 1 because that's a ratio of like the same over the same, that will make it 1. So then multiply it together, we have 4ac all over 4a times a, so that's 4a squared. That's equal to x plus b over 2a squared. Now, let's take the square root of both sides. Now remember, from algebra, if they have the same denominator, they can be written as one numerator and one denominator. So that becomes 4a squared on the bottom and b squared minus 4ac all on the top. Now our square and our square root will cancel here, so we're left with x plus b over 2a is equal to the square root of b squared minus 4ac all over the square root of 4a squared. Now this is to say that the square root of a fraction is the square root of the top part of the fraction divided by the square root of the bottom part of the fraction. That's what we did here. So now when we simplify this out, we have square root. Oh, and if we take the square root of both sides, then this side has to be plus or minus. So we have the plus or minus on this side. And so then we have plus or minus b squared minus 4ac all over the square root of 4a squared. Well, that's the square root of 4 times the square root of a squared. Square root of 4 is 2. Square root of a squared is a. Now we have b over 2a and all of that over 2a. So we can move that to one side. So we have x plus b over 2a is equal to that. Now let's isolate x, the easy part. So we have x is equal to, so we minus b over 2a from both sides. If we minus b over 2a from this side, that'll isolate our x. And what do we have? X is equal to negative b all over 2a plus or minus the square root of b squared minus 4ac all over 2a. And that, my friends, is the same as that because we simply put it all under the same denominator. Negative b plus or minus the square root b squared minus 4ac all over 2a. Well, I hope y'all followed along and maybe learned something from this. I appreciate your time. Thank you for watching.